this is our first online lecture. If you have any questions or any concerns, please don't hesitate to email me. So let's start with what we know. So we know to take derivatives, right? So we know how to take derivatives, and let's take some since we know how to do it. So let's see. We have, let's say, the function f of x, which is equal to x to the third plus x squared plus 50. Okay, let me take the derivative of that. So f prime of x will be what? So I have here the power of 3. What I do with the power, I will put it here in the front of it. So it will be 3x. Here I will subtract 1 from the power. So it will be 3 minus 1 will be 2, correct? Now plus, how about x squared? I put 2 from square. I have x and it will be 2 minus 1, right? The derivative of a constant, it's always 0. Very good. So it's always 0. Let's have g of x. So the g of x, let's have it as x to the third plus x squared plus 85. Okay, so let me take the derivative of g of x. Okay, so once again, x to the third will be 3x squared plus x squared will be 2x, and the constant derivative of a constant is 0. And let's have h of x. So we have this h of x as x to the third plus x squared minus 150. Okay, so let's take the derivative of it. H prime of x is equal to 3x squared plus 2x, derivative of a constant, so once again 0. So if we look at these three functions, we can see that they are not the same, correct? Each function is differ by a constant from the next function. So you cannot say they are the same, correct? But if I take the derivative of each of these functions, we can see that the derivatives are exactly the same, correct? So what does it mean? It means then that infinity number of functions share the same derivative. Because it doesn't matter, I can choose any derivative I want, and I have infinity many choices, right? If I take as a constant, and if I take the derivative of it, then I will have exactly the same function. So let's see if we have to find the general form of the function that has derivative as f of x is equal to x. So how can we do this? We can write it, right, like d over dx of my function f of x, okay? And I know if I take the derivative of this function, I will have to have, this should be x, correct? So let's figure out what is this function, f of x. So f uppercase f of x is equal to, I know I take the derivative, I have this function and I take the derivative and I will have an x. So the power on my original function, uppercase f of x, has to be 1 greater than the power of the function. I took the derivative already. So this power is what? Is this power is 1. So this power will be x1 and I have to add 1, correct? Because now the derivative of this will be what? Which is x squared. Okay, but I'm not done. The derivative of this will be what? Will be 2x. So I am good here. But here I do not. Do I have x here? No, I don't have this x. So what can I do to get rid of that x? I can divide by these 2. Correct? And let's see if this is correct. Let's take the derivative of f prime of x. Okay? So I know that my f prime of x is x squared over 2 derivative. Correct? So derivative of x squared is 2x over 2. So my answer is x. And here we are. But are we done? No, we are not. Why are we not done? We are not done because, do you remember here that I can take a derivative of this function and I get this, right? But I also can take derivative of this function and I also get the same thing. And I also can take derivative of this function and I also get the same thing, correct? So what should I do to show that? I have to say that I can have any constant and that will do not change the derivative, correct? So I can have any constant there, and then I'll have the same derivative. Correct? So now, this is what antiderivatives look like. Let's have the theorem. So, antiderivatives. If the derivative of two functions are equal on an open interval AB, so the derivative of two functions, like we have the derivative, they are equal in this interval AB, then the function differ by at most a constant. Is that right? Yes, because these two derivatives, actually these three derivatives, so these two derivatives are exactly the same. What does it mean about these functions? These functions differ only by these constants, correct? Okay. Symbolically, if f and g are differentiable functions on the interval AB and f prime of x is equal to g prime of x, which this is true, f prime of x is equal to g prime of x and is equal to h prime of x. For all x in this open interval AB, then f of x is equal to g of x plus that constant. So that is very important, like here, was very, very important to add this constant, correctly? Correct? Because we are not talking about having one solution, like I said before. We are talking about having infinity of functions that have the same derivative. If you have one derivative and you have to take it, you'll have an infinity number of functions that can have that derivative. So, okay, for some constant k. Alright, now let's see the formulas and let's learn them, so we'll go ahead and it will be easier for us to solve this indefinite integral. So, formulas and properties of indefinite integral. For c and k, both constant. So, integral of x to the n dx. So, do you remember what we did here? We add 1 to the power. So, if you take integral of x to the n dx, it's equal to x to the power of n plus 1 divided by n plus 1. And we cannot forget what? About that constant, right? Plus the constant. And also, we have to remember that in this case, right, n cannot be equal with -1. Because if n is equal to -1, we have division by 0. So we can have that. The second one, integral of e to the x is equal to e to the x plus c. If I take the derivative of this, what do I get? I will get e to the x. Very good. Integral of 1 over x dx is equal with natural log of absolute value of x plus c. Or once again, we have to put a condition that this x cannot be 0. Correct? So, if you have an integral of a constant k, any constant k, times the function, and dx, you can take the constant in front. That will do not affect you taking the derivative of the function. And number 5, if you have integral of two functions added or subtracted together, then you can write that as the sum of the integral of the subtraction of the two integrals. Okay. So will be integral of f of x dx plus minus whatever you have, whatever sign you have there, integral of g of x dx. Alright, so now let's do some exercises. Okay, all the exercises. The first one. we'll do 3 exercises first. So in problems 1, 2, 3, find each in the indefinite integral and check by differentiation. Okay. Okay, let's start with the first exercise. So in each problem we have to find the indefinite integral. Okay. So in exercise 1 we have integral of 26x dx. Okay. So let's see what this one is equal to. So we know what? We know that y is equal with integral of 26x dx. So which of the formulas from here we are going to apply? The first one. So let's do it. You can pause the camera for a second and then you can solve it by yourself and see if you get the same exercise, the same answer. So we have what? We have 26, right? Integral. We can use number 4 because we have the constant, so we can put the constant in the front, and then we have x dx. And then I have 26, and then I have x. What do I have to do here? I have to see what power it's x at. My x is at the power 1, so I have 1 plus 1 over 1 plus 1, correct? And then plus c. Don't forget that c, because you do have infinity many solutions, and if you choose just one, that's not sufficient, is it? So let's see here. So this one is equal to 26, and here x squared over 2 plus my constant c, and this simplify. So I have 13x squared plus c. So now I find this. Then I have to check by differentiation, right? So y is equal to 13x squared plus c. Okay. Now I do what? I do dy over dx. dy over dx. It's equal to. So what is derivative with respect to x of 13x squared? That will be, you take the power, you put it in the front, and you have 2 times 13 stays the same, x to the power 2 minus 1. Constant, derivative of a constant, once again, it's 0. So this is equal to 2 times 13 is 26x. This is what we have. Let's see what we start with. Therefore, check. That is correct. Let's do the second one. So the second one is this one. So let's see, number 2 is integral of 9x square root of x dx. Okay. So let's see once again. Let's see which property we use. We have a constant. What do we do with constants? We always put a constant in front of a integral. So we have 9 integral of x 1 over 2. This is square root, correct? dx. So this is equal to 9. The constant stays the same. Now we have x. X to what power? Well, x to the power 1 over 2 plus 1 divided by 1 over 2 plus 1. To can add, if I have fraction, to can add the 2 fractions together, what I have to do? Common denominator. So what should be the common denominator? Should be 2. So how can I write 1 to have a 2 in the denominator? I can write it as 2 over 2, right? And then plus the constant. Never forget the constant. So this is equal to what? X to the power of nothing. Let's put a 9 there. Don't lose the 9. So 9x to the power of 3 over 2 over 3 over 2, correct? Plus my constant c. Now I can multiply it, and I will have 9 times x to the power 3 over 2 times 2 over 3 plus the constant. Okay, so this simplifies, this is 1, this is 3. So this will give me equal to 3 times 2 is 6, x to the power of 3 over 2 plus c. Now we have this answer. What do we have to do next? We have to check by differentiation. So what is my y? Y is equal to 6x to the power of 3 over 2 plus c. Then what is dy over dx? Let me take the derivative of it. So I will have 3 over 2 times 6 x to the power of 3 over 2 minus 1. What is the derivative of a constant? The derivative of a constant once again is 0. So this, it's 1, it's 2, and then 3 times 2 is, no, this is 3. Okay, 3 times 3 is 9. And then we have x. Okay, I have to can subtract fractions, I have to have the same denominator. 3 minus 2 is 1 over 2. So this is my answer. Is that the same with the initial? Yes. Well done. Let's see the third one. The third one, we have integral of 7 e to the x dx. And this is equal to, once again, what do we use? Which of the properties? Property number 4 first. We have the constant out. And then, now which property we are using? Property number 2. What's the integral of e to the x? It's e to the x plus the constant. Now we know that y it's equal with 7, let's say y, is 7 e to the x plus c. What is dy over dx? Let's take the derivative to check. Check. And this is equal to 7 e to the x, 7 times e to the x is e to the x, derivative of a constant is 0. So this is what I have. 7 e to the x, 7 e to the x, that's correct. Okay, so now let's do the next exercises. So 4, find all the derivatives for dy over dx. It's equal to 7x to the power of minus 1 plus 3. So what do we have? We have dy over dx is equal to 7x to the power of negative 1 plus 3, correct? So from here, we know that dy is equal to 7x to the power of negative 1 plus 3 dx. So let's take the integral of both sides. Integral of dy it's equal to the integral of 7x to the negative 1 plus 3 dx. So if I take the integral of this I will get y, it's equal to, okay, so let's see, integral of 7x to the negative 1, integral of 7, so 7 can come first, right, from number 4, then x to the power of negative 1, I know that it's natural log of absolute value of x plus c, right? So natural log of absolute value of x plus a constant. Plus, I have this 3, okay, this is just a constant, I can put it in the front, so I have this 3 as a constant, and I have an integral dx, right? This is plus a c from here, c1, let's put it. And then I can write this one as 7 natural log of absolute value of x plus 3. So here we have 1, or we can write it x to the power of 0, correct? So since I have x to the power of 0, by number 1 I will have what? X to the power of 0 plus 1 over 0 plus 1, correct? Plus this, let's say, I have another c now, because I have a constant from here, constant from there, and I will put it just as a c. Okay, so this one, it's equal to 7 natural log of x plus 3 times x to the first power over 1, but I'm not going to write it, plus c. Okay. Now, let's go to the next one. In the problems 5 to 8, okay, let's go ahead. Okay. In the problems 5 to 8, find each in the integral. So let's start with number 5. 5, it's integral of x to the 5th times x to the 3rd plus 7x squared plus 6 dx. Okay, so I have this. Now I know that I have x to the 5th, let's just distribute that. So we'll have integral of x, 5 plus 3, it's 8. And then I will have plus 7. Now 7x squared times x to the 5th will be x to the power of 5 plus 2, it's 7. Plus 6 times x to the 5th dx, right? So this will be equal to, from the first one we use the property number 1, so we'll have what? X to the power 8 plus 1 over 8 plus 1, so it's 8 to the power of 9 over 9, plus 7, there's the constant, times, because we'll put the constant at the end, because the constant can be, so 7 times this x will be to the power of 7 plus 1, which is 8 over 8, plus 6 to x to the power of 5 plus 1, 6 over 6, this simplifies, plus the constant, right? So therefore my answer is x to the power of 9 over 9 plus 7 x to the power of 8 over 8 plus x to the power of 6 plus my constant c. Let's do the next one. So number 6, it's integral of 3 over x squared minus square root of x to the 5th dx. And I highly recommend you to stop the video and try to do this by yourself, and after you have done it, then you can play the video again and see if we can get the same results. So go ahead. Okay then, welcome back. Let's see how we solve it, and let's see if we have the same result. So let's write this one in a form what is more advantageous for us and easier to look at these formulas and properties and then to find the result. So let's start here. We have integral of what? 3x to the negative 2 minus x to the power of 5 over 2, right? Because it's squared. And this is dx. So what is this equal to? This will be equal to what? 3x. What do? We have this 3, right? From property number 4 that you put in the front. From this first one, we have x to the negative 1, right? And then minus x to the power of 5 over 2 plus 1 over 5 over 2, right? And then plus a constant. Okay, so once again we have a fraction. How do we add fractions? To be able to add fractions, we have to have the same denominator. How can I write 1 to have 2 in the denominator? I can write it as 2 over 2, correct? So let's do the same in both. So now I will have what? This will be equal to 3x to the negative 1 minus x to the power of 7 over 2 and divided by also 7 over 2, but I can flip it, right? I can multiply it by 2 over 7 plus the constant c, therefore it's 3x to the negative 1 minus 2 times x to the power of 7 over 2 over 7 plus the constant c. Okay? Right, so, okay, and let's see if we have it done correctly. So we have what? We have 3x to the negative 2, I add 1, so I get negative 1, and I have to divide it by negative 1, right? And here, once again, I have to divide it by negative 1. If I divide it by negative 1, then I will have the negative there. Okay. Good. So, next one. So don't forget to divide. Number 7. Number 7, we have integral of 9x plus 2 over x to the 4th dx. Okay, so let's see what's this one equal to. This one is equal to integral, I'm going to write it as 9x over x to the 4 dx plus integral of 2 over x to the 4 dx, right? Or I can just write it in one, doesn't. And that's equal to, now will be integral of 9x to the negative 3, let's put it both together, plus 2 times x to the negative 4. dx. Okay. So this one, it's equal to 9 times x to the power of negative 2 over negative 2 plus 2 times x to the power of negative 4, 4 minus plus 1, so it will be negative 3, right? Because negative 4 plus 1, it's negative 3, divided by negative 3 plus the constant c. Okay? So this will give me negative 9 over 2x to the negative 2 plus 2 over 3, but this one is also negative, so I'm going to write negative x to the power of negative 3. So you can write it as negative 9 over 2 x squared minus 2 over 3 x cubed in the denominator plus c. Okay. Let's do the next few more exercises and we'll be done. Now, number 8. Okay, let's see. Number 8. So, same thing. Integral of 5x to the 5th plus 3x to the 6th times e to the x divided by x to the 6th dx. So let's solve this one. Once again, we'll do the same thing. We'll separate them and then we'll divide it by this x to the 6th, so it will be much easier to solve. So we have integral of 5x to the 5th. Okay, let's write it. X to the 5th over x to the 6th, so you have no question where these numbers are coming from. Plus 3x to the 6 e to the x over x to the 6. X to this, you see, dx. You see here, it's a multiplication, and I have division, so I can simplify. Now, this will be equal to, okay, so I have 5x to the 5th divided by x to the 6, so it will be integral of 5x to the negative 1, right? Because 5 minus 6 is negative 1. And here I will have plus 3e to the x and dx. This one is equal to, okay, so I have 5x to the negative 1. I put the 5 in front. Integral of x to the negative 1, we know from here that will be here, right? Negative 1 will be natural log of absolute value of x, correct? Plus, then I have 3, I have the constant, you put it in the front, e to the x, integral of e to the x is e to the x, and we have the constant. That's all is to it. So, let's go next. Problems. Okay, so in problems 9 to 12, find the particular antiderivative of each derivative that satisfies the given condition Okay, so what is the condition? Condition. Okay. Number 9, r prime of x is equal to 4x to the third plus 12x minus 5. And I know that r at 2 is equal to 50. So when we have to find the particular antiderivative of each of these derivatives, right, that satisfy the given condition, I have this one as r prime of x equal to this. So I have to take integral of both sides, right? So therefore, integral of r prime of x is equal to, okay, so I can write it r of x for simplicity. Okay, r of x is equal to integral of 4x to the third plus 12x minus 5 dx, right? So what's this equal to? This will be 4, it's a constant, I put it in the front, I have x to the third, I add 1, so it'll be 3 plus 1, it's 4 over 4, plus 12x to the first power, it's 1 plus 1, it's 2, over 2, right, minus 5, it's x to the power of 0, right? So 0 plus 1, 0 plus 1, it's 1, and then divided by 1 is the same, so it'll be just x to the first power, and plus my constant, right? So here I can simplify it a bit, so therefore this will be equal to x to the fourth plus 6x squared minus 5x plus c. So if you do not have this part, you'll be done. But you are not, because I want a particular antiderivative of each derivative that satisfies this given condition. So I know what? I know that r, I have this r of x, but what happened here? I have r of 2. So each time I see this x, I'm going to change it to 2, and then the answer should give me 50. So let's do that. So I have r of 2, and here I see an x, so I'm going to write 2. Plus 6, I see another x, I'm going to write another 2. Minus 5 times 2 plus c, and I know that this one should give me 50, right? So 2 to the fourth is 16, plus 6 times 4 is 24, minus 10, plus c, it's equal to 50. So let's see what c is, and from here, see what I have to do. I want to keep c in one side, and I have to move everything on the other side. So I add 10, I subtract 24, and I subtract 16, correct? So 16 plus 24 is 40. 40 minus 10 is 30, so minus 30 here. So I know that c should give me 20. So in other words, in this particular antiderivative will be r equal to x to the fourth plus 6x squared minus 5x plus 20. Now let's do another one. Let's try this again. 16, 6 times 4. Okay. Now let's go do the next one. Number 10. And I want you to stop once again. I'm going to write what number 10 is, and I want you to stop and I want you to do it by yourself, and then I want to see if we have the same answer. So, number 10, we have dy over dt, it's equal to 5e to the t plus 4t minus 8. And I know that minus 8. And I know that y at 0 is equal to 8. So let's do it. So dy is equal to 5e to the t plus 4t minus 8 dt. Right? Next, we have to take the integral of both sides. So we have y is equal to 5e to the t. By number 2 we know it's e to the t. Plus 4, we have t to the first power, so it will be t squared over 2. Minus 8, and then you put x to the first power divided by 1, so it's just 8. Plus c. Okay, so this is just a 2. So therefore, y is equal to 5e to the t plus 2t squared minus 8t. It's t, it's a function of t now, right? So minus 8t plus c. And I know that at 0, it's y at t, y at 0, it's equal to 5 times e to the 0 plus 2 times 0 square minus 8 times 0 plus c. This should give me 8. And from here I have 5, right? 5 times 1, because any number to the 0 power it's 1, so I have 5 plus c, it's equal to 8. Then I subtract 5 from both sides. Therefore c is equal to 3. So what is our particular antiderivative? So it will be y of t, it's equal to, instead of c I'm going to put 3. So I have 5e to the t plus 2t squared minus 8t plus 3. Okay, now let's do one more and be done with it. So dt over dx is equal to 6x to the third plus 5x divided by x to the third. I know that uppercase D of 10 it's equal to 50. So once again, D it's equal to, I'm going to write it as 6x to the third over x to the third plus 5x over x to the third dx. Now I'm taking the derivative of both sides. And from here I will have d of x, it's equal to, this can simplify, right? So it will be integral of 6 plus 5x to the negative 2, because it's to the negative 3 plus 1 negative 2, and this is a function with respect to x, function of x. So this is equal to, then integral of 6 will be 6x, right? Because this is x to the power of 0 once again, and we add 1 here, so will be x to the first power divided by 1. Okay, so plus 5, this is negative 2 plus 1, it's negative 1 over negative 1 plus a constant c. So this is equal to 6x plus minus 5 divided by x plus c, and I know that d of 10, what do? Each time I see this x, I'm going to plug in a 10. I'll have 6 times 10 minus 5 over 10 plus c, and I know this one should give me 50. And from here, I know that c, it's equal to, I'm going to just subtract this 60 and add this 5 over 10. Subtract 60 and add 5 over 10, this is 1 over 2, right? Because I can divide it by 5. This is just 1 over 2. So what is my c? 50 minus 60, it's minus 10, plus 1 over 2. I do have to have the same denominator, we can add them. So I'm going to multiply this one by 2 over 2. So I will have negative 20 plus 1 over 2, and it's equal to negative 19 over 2. Okay, so how I can write this one? So I write d of t, it's equal to, here, 6x plus 5 over x, this is with minus, and then plus, and my c value, I can write it as minus, once again, minus 9 over 5. So 6x, that's the answer, and thank you very much, and see you next time.